Okay, it's been a while since I've recorded a video, but I'm back today with trapezoidal sums. Now, they're used to approximate the area under a curve, not very effectively, but they are tested on the AP test or the AP Calculus AB and BC exam. And they're pretty similar to the Riemann sum. In fact, the formula for a trapezoidal sum is the left Riemann sum plus the right Riemann sum over 2. And this can be derived from the fact that the area of a trapezoid is equal to 1/2 base times height 1 plus height 2. And since we're using right Riemann sums and left Riemann sums, we're doing this multiple times. So imagine you have a curve like this. You're basically approximating this value plus this value plus this value, etc., depending on how many subintervals you use. And the more subintervals you use, the more precise your answer will be. Now, if the curve you're approximating is concave up, meaning it's accelerating essentially, and then this trapezoidal sum will be an overestimate. Likewise, if it's concave down, then it's going to be an underestimate. Okay, so this question here asks us to approximate the value from 1 to 7 f of t dt. It tells us to do so with a 3 subinterval trapezoidal sum. Now, as I said earlier, a trapezoidal sum is equal to the average between the left Riemann sum and the right Riemann sum. So let's start off by identifying the subintervals we're going to use, which in this case we'll use from t equals 1 to t equals 3, from t equals 3 to t equals 4, and from t equals 4 to t equals 7. So a left Riemann sum can be found by multiplying delta t or delta x, whatever it may be, times the left value of each interval, which in this case is going to be f of 1. So we'll say that 2, which is the difference between 3 and 1, times f of 1 plus 1 times f of 3 plus 3 times f of 4 is equal to the left Riemann sum in this case. Now all we have to find is the right Riemann sum and average the two out. So we're going to add this together. We're going to start over here. The rightmost sum in each interval, or at least in this one, is 27. And we're going to multiply that by delta t, which is 3. So 3 times f of 7 plus 1 times f of 4 plus 2 times f of 3, all over 2. So from here, we can substitute our values in. F of 1 is 10. F of 3 is 15. F of 4 is 18. F of 7 is 27. F of 4 is 18, and F of 3 is 15. So we have all our values in place. I've already done the calculations. This is equal to 109. Sorry, I should have said earlier that, or I should have indicated earlier that this should be an approximation sign since we are approximating. But that is the approximation for this value. Okay, this is the final practice problem for today. We're told to approximate the area under the curve of y equals x squared on the interval 2, 8 using 3 subintervals. So as always, let's say what the definition of a trapezoidal sum is. And now we can just fill in the blank. And to make this easier on ourselves, let's make delta x constant, and let's use the subintervals 2 to 4, 4 to 6, and 6 to 8. Okay, so let's first find the left Riemann sum, which is going to be delta t, which is 2 in this case, times f of 2. I'm going to have to erase this, plus delta t again, which is going to be 2 times f of 4, plus 2 times f of 6. And from here, sorry, this is our left Riemann sum. Now we have to find our right Riemann sum. delta t is going to be, sorry, delta x in this situation is going to be the same. 2 times f of 8 plus 2 times f of 6 plus 2 times f of 4. Thankfully, delta x in this situation is 2, so we can just cross out every instance of 2. And we're left with the trapezoidal sum being equal to f of 2 plus f of 4 plus f of 6 plus f of 8 plus f of 6 plus f of 4. So we can substitute these values in. F of 2 is equal to 4 plus f of 4, which is 16, plus f of 6, which is 36, plus f of 8, which is 64, plus f of 6 again, which is 36, plus f of 4 once more, which is 16. And this, I believe, is equal to 172. So the area under the curve is approximately equal to 174. Sorry, I believe this is actually 172. 1 on the interval, 2 to 8 using 3 subintervals. That's it for today's lesson. Leave suggestions in the comments for what you want next time.